Today we will solve the problem 2.26 of Griffith 4th edition, Introduction to Electrodynamics. The problem 2.26 is a conical surface, that is an empty ice cream cone, carries a uniform surface charge sigma. The height of the cone is h, as shown in the figure, as the radius of the top, that is, the radius also equal to h. Find the potential difference between point A, the vertex, and point P, the center of the top. That is, this is point A. Potential at point A is VA, and potential at point P is VP. So now we have to find out VA and VP. Here, interestingly, you can note the diagram. This distance is taken as script R. So naturally, script R squared is equal to this h squared plus this h squared. So you will get 2h squared. So what is script R? You can take square root of this. That is square root of 2 divided by h. If instead of h, you can take any other value. Let us say we are taking R, we are generalizing the problem. So which is less than this h? We are taking some distance R. So this can be written as script R is written as square root of 2 script R. Sorry, square root of 2 small r. So now another parameter we need is this theta. What is this theta? By definition, tan theta is equal to opposite side. This is the opposite side, h, divided by this adjacent side, this one. So this is h. h divided by h is 1. So tan theta is 1 if theta is equal to pi by 4. So this angle is clearly 5 by 4, no doubt about this. This is 5 by 4. Now we will come to our original problem. What is V of A, which is equal to, by definition, is equal to 1 over 4 pi epsilon naught integral between 0 to this length. What is this length? Script R. Script R is uh, square root of 2h. So we are integrating between 0 to script R, that is square root of 2 over h. Then sigma dA, small area element segment, divided by script R, d script R. Now TA is equal to 2 pi r, Here we can replace r using this formula. So from this, r is equal to script r. I will write script r like this, maybe. So this is script r divided by, you bring this square root to the left hand side, equal to square root 2. So I have replaced this r by script r divided by square root 2. Now we will simplify this one. So we have seen V of A is equal to 1 over 4 pi epsilon naught integral between 0 to square root of 2h sigma multiplied by 2 pi script r divided by script r square root of 2. Now we can cancel some of the things. See, you can cancel this 2 pi and this 4 pi, which will become 2. Then you can cancel this script r and this script r. So now you take the constant outside. That is constant here is sigma. 2 times here you have square root 2. 2 times square root 2 multiplied by epsilon naught, and this integral simply will become t script r. So if you integrate, you will get a script r. If you apply the upper limit, this is square root h. Lower limit is 0. So this integral will be square root of 2 h. Now you can cancel this square root and this one. So you will get sigma this h, sigma h divided by 2 epsilon naught. So V of A, potential at this point, is equal to, we have calculated as sigma h divided by 2 epsilon naught. Here this is the potential. Now we have to find the potential at this point. So we have found the potential at point A, that is V of A we have already calculated. Now we have to find the potential at the point P, this point. So for that, what we are going to do is we are considering a small circular disc like this as shown in the blue color, and we are taking a point from script R to this point. Remember that script R is variable. In previous case also we have integrated over script R. That means script R is a variable. So what is this R prime? Using cosine law, this R prime, we can write this R prime. Here the R prime is enclosed by two arms. That is this side h and this side script r. So according to cosine rule, the script r is equal to square root of h square, this one, h square script r square minus 2h script r cos theta. Remember that here theta is equal to pi by 2. Already we have, sorry, pi by 4, already we have seen. So now what is V of P, which is equal to 1 over 4 pi epsilon naught integral integrating 0 to square root 2 h sigma 2 pi r divided by script r prime t script r. Now what is r? We are replacing r by script r divided by square root 2 from this. Already we have seen script r is equal to square root of 2 pi r. So naturally r is equal to, you bring this script r to the left hand side. Sorry, square root of 2 to left hand side. So this will become script r divided by square root 2. So that's what I have written here. Now what I'm, and also I have replaced this script r prime, which is equal to h cross squared plus script squared, sorry, h squared plus script squared script r squared minus 2h script r cos theta. I have replaced this. Now we can bring some of the term here. See, here you have 2 pi. As usual, this 2 pi will get cancelled with this 4 pi, which will become just 2. Now here square root 2 will come in the denominator, and sigma I am taking out. So sigma 2, this square root 2 epsilon naught I am taking outside. Then inside this one, sigma also I have taken. So inside the integral you have script r. Other thing I have taken out. Script r divided by square root of h squared plus script r square minus 2h script r cos theta. Now we will integrate this one. So now we got this expression. Here we know this theta value is pi by 4. This theta equal to pi by 4. So cos pi by 4 is square 1 over square root 2. So here you have 2. So naturally 2 divided by square root 2, which will become square root 2. Square root 2. So I have taken square root 2 h script r. I have changed the third term to square root 2 h script r. Now this h cross squared I am going to write as sorry, not h cross squared, h squared I am going to write as h squared by 2 plus h squared by 2. So I have written like this. So if you take these three terms, what will happen? This is exactly equal to script r minus h divided by square root of 2 power whole squared. So if you expand this, you will get this. That is a squared script r squared plus b squared. That is h squared divided by 2 minus 2ab. 2 times a is script r, b is h divided by square root 2. So naturally you will get to square root 2 divided by so you will get to square root 2 h script r. So I have rewritten as this square root of r minus h divided by square root of 2 whole square plus h squared divided by 2. So V of P is this one, we got it. Here you can see in the denominator square root term, you have one variable, square of one variable and square of one constant. If denominator is in the form of x squared plus a squared, that is one variable and one constant like this, then you can make a trigonometry substitution, preferably tan theta. So now we can take these terms inside the bracket. Script r minus h divided by square root 2 is equal to h divided by square root 2 tan theta. So now if you bring this to the right hand side, this will become plus. So this can be rewritten as script r is equal to h divided by square root of 2 1 plus tan theta. Now if you differentiate this, that is t script r is equal to the first term is a constant, will become 0. Then the next term h divided by square root of 2. If you differentiate tan theta, you will get secant square theta t theta. Now substitute all the three here. So first substitute for script r. Script r is this one. I have replaced script r by h divided by square root of 2 1 plus tan theta, and t script r, this one, h divided by square root of 2 secant square theta, of course t theta, and this I have replaced this by this one. That is, we know that we have taken r minus h divided by square root 2 is h divided by square root 2 tan theta whole square. Now this h squared by 2 we can write as h divided by square root 2 whole square. Now you take this constant outside, that is h divided by square root 2 whole square is here. Similarly here h divided by square root 2 whole square is here. So if you take this out, this will become, because this is 1 over h square root of 2. So this will become square root of 2 divided by h. And what will happen to the numerator? In the numerator you have 1 h cross, h divided by square root 2, h divided by square root 2, which will become h squared divided by 2, this one. And this we have taken here. In the numerator you will have 1 plus tan theta secant square theta. In the denominator we have tan square theta plus 1, because we have taken already h divided by square root of 2 whole square. So which will become, if you take out of square root, it will simply become h divided by square root 2. That's what I have written here. So now we will try to simplify this. Now we got this expression. We can cancel some of the terms here. That is, this h cross, h squared will get cancelled with this h, and square root of 2 will get cancelled with this square root of 2. Then this 1 plus tan squared theta is equal to secant squared theta. Since there is a square root, square root of secant squared theta will become secant theta. Then that secant and this secant squared will get cancelled. Now you can see in the denominator you have sigma h, and in the numerator you have sigma h, and in the denominator 2 into 2 4 epsilon naught you have. Then here in the integral you have 1 plus tan theta secant theta d theta. Then this can be separated into two integral. That is, one is secant theta d theta, other one is tan theta secant theta d theta. Of course, this multiplicative factor will come. Now you can see this is secant theta is even and tan theta is odd. So if you integrate add integrand between the symmetrical limit, this will be 0. This is 0. Then what will happen to first term? First term, you can see you can change the integral limit from 0 to pi by 4. So there will be a multiplicative factor of 2. So that 2 and this 4 will cancel. This will become 2. So sigma h over 2 epsilon naught, integrating between 0 to pi by 4, secant theta d theta. Now we will solve this integral. Now we have to integrate this one. So if you integrate secant theta, you will get natural logarithm secant theta plus tan theta. Now you have to apply the limit. Lower limit is 0, upper limit is 554. First apply the upper limit, that is secant 5 by 4 plus tan pi by 4. So this secant 5 by 4 is square root 2, and this tan pi by 4 is 1 for upper limit. So this will become natural logarithm of square root of 2 plus 1. Now you come for the lower limit. For lower limit, secant 0 plus tan 0, minus minus secant 0 plus tan 0. So secant 0 is 1 and tan 0 is 0, 1 plus 0. So you will get. So you will get natural logarithm of 1 minus, because lower limit, minus natural logarithm of 1. So the value of natural logarithm of 1 is 0. This will be 0. So you will get the potential at P is equal to sigma h divided by 2 epsilon naught natural logarithm of square root 2 plus 1. And already we know this is V of A and this is V at P. If you subtract both, that is the potential difference between A and B. You can take sigma h divided by 2 epsilon naught as a common factorial, common parameter, then this will become 1 minus natural logarithm of square root of 2 plus 1. So thank you very much for watching my video and supporting me continuously. Thank you very much.